the product theorem allows us to multiply two vectors in polar form. So if you had something like this, 8 cis 40 degrees times 2 cis 13 degrees, we're going to end up having 16 cis 53 degrees. That's the product. So in general form, I like its compact form. You multiply the two magnitudes, and you're going to add the two angles. So let's see an example. Example 6, find the product of these two vectors. So let's write it in abbreviated form. 3 cis 45 degrees times 2 cis 135. We're going to multiply the magnitudes. 3 times 2 is 6. And we're going to add the angles. 45 plus 135 is 180. So really that's it. That's the product. But they ask us for rectangular form. So that's what makes this problem a little bit more complicated. Remember, rectangular form, we're going to need x and y. We have currently r and theta, but they want x and y. So we have formulas for that. X is going to be r times cosine theta, and y is going to be r times sine theta. Cosine 180. Maybe we want to draw a picture of 180. About 180 degrees is over here. So if you think about it from a reference angle, that's a 0 degree reference. And so you want to look at cosine of 0. Cosine of 0 is 1. But if you think about where we are over here on the left side, cosine 180 is going to be negative. Cosine is negative on that left side. So cosine 180 is negative 1 times the 6, gives me an x component of negative 6. As for sine 180, again we're over here, but sine 0 degrees is 0. So sine 180 is 0, we have 6 times 0 is 0. So if we have to write this in rectangular form, this was polar form, but if I have to write it in rectangular form, take your x component plus your y component with an I. Now, of course, we can simplify that and just say negative 6. And I suspect Math Excel is going to make us simplify, but honestly, I would prefer if you left it in xy form like this. Negative 6 plus 0i. So if we do the quotient theorem allows me to divide. So if you had something like 40 cis 100 divided by 5 cis 25, we're going to get 8 cis 75. And so hopefully you can see that we're going to divide the magnitudes. We're going to subtract the angles. So there's a rule for that. Example 7 uses the quotient rule to divide two vectors. We can see 10 divided by 5 is equal to 2. And then we're going to subtract the angles. Negative 60 minus 150 is negative 210. So we have 2 cis negative 210 degrees. That would be awesome if we could leave it, but since this wants rectangular form, they're wanting x and y. Okay? What we have is polar form with r and theta. So rectangular form is going to look like x equals 2 cosine negative 210 degrees, y equals 2 sine negative 210 degrees. So let's look at 210 degrees, or negative 210 degrees. Negative 210 takes us past negative 180 into the second quadrant. It's a 30-degree reference in the second quadrant. So when you do cosine negative 210, it's kind of like you're doing cosine 30. Cosine 30 is square root of 3 over 2. But think about where we are. In the second quadrant, cosine is going to be negative. So cosine negative 210 is negative square root of 3 over 2. We're taking this 2 times negative square root of 3 over 2, and that's a negative square root of 3. If we do sine negative 210, that's like sine 30, and sine 30 is 1/2. So again, think about where we are in the second quadrant. Sine is positive there, so sine negative 210 will also be positive 1/2. And so the y coordinate is going to be 2 times 1/2, that's 1. So if you have your x component and you have your y component, then we should have rectangular form. Rectangular form is going to look like negative square root of 3 plus 1i, or just I.